Hey everyone, so today I'll be presenting about threat modeling and yeah, I'll start with my dad. Like my dad is a great threat modeler. So we will learn threat modeling with the reference of my dad. So first thing first, something about me. I work as a security engineer at Finoa. I suffer from voluntary stress because like you can find me volunteering with almost every conference, working behind the scenes. I'm more of a security wrangler than an engineer. I live on the principle of fucking around and finding out the landmines in the organization, infrastructure, and architecture. You can always find me on Twitter and Discord. So let's start. Okay. So as once Dan Kaminsky said it during DEF CON 23, who are we? Who are the hackers? Like, we are the people who manipulate how systems really work, not just merely how they are supposed to work. And that does not always mean we know how they work. It helps, but we don't always know. And not knowing how things work tends to cause them to fail. And we hackers just define the failure condition as a success condition. When every engineering team fails, security team wins. And like we in security think that other people can make mistakes and fall into pits, but we security folks are immune to everything. But believe me, we screw things all the time. But we just have an attitude about it. So threat modeling. What is threat modeling? Like by definition, threat modeling is a structured approach of identifying and measuring risk or prioritizing them, determining the value that potential mitigations can reduce or neutralize those threats. In general, when we proceed to threat modeling, there are four questions which comes in our mind. First is what are we building or what we are looking at? What could go wrong? Either it's an infrastructure application or maybe a physical building. You can threat model anything, any infrastructure, anything. It reminds me of last week I was attending Dana Initiative virtual conference and there was a talk about threat modeling your mental health. And like it was a superb talk. Then we can identify threats by thinking what could go wrong. And then when we recognize threats, then we need to understand what we are going to defend us against those threats. And the final step will be like if we know that there are threats, we know from whom we have to defend ourselves. Now, are we acting on those steps or not? If we have acted, then what's the residual risk now? I'll start with some boring frameworks to get the basic understanding. I won't go deep into them, I promise. And like as usual, no one likes doing things in theory. So let's start with Octave. Octave is more like practice focused threat modeling framework, and full form of Octave is operationally critical threat asset and vulnerability evaluation framework, which basically defines the risk, which basically defines strategy based on risk assessments and planning techniques. Like Octave is a self-directed approach. When you are starting with Octave, it it just gives you a variation of tailored limited means that you have unique constraints limited to your organization size. There's one more variation of Octave, which is like Octave S, which is used for the teams less than 100 people and having a threat modeling function of only just 3 to 5 people. Second is Strike. Strike is mostly works with in reference with ERM, and what ERM is enterprise risk management. So it mainly works as a risk management tool. Within this framework, threat models are used to satisfy the security auditing process. Threat models are based on requirement model, and the requirement model establishes the stakeholder defined acceptable level of risk. Now, what this acceptable level is? We'll talk about it later when we will be talking about risk acceptance and risk tolerance. Then analysis of these requirement model yields a threat model from which threats are enumerated and assigned a particular risk values which ties to the business risks. Then third, Stride. Stride is quite popular and it's mostly a developer focused threat modeling technique. Stride stands for spoofing, tampering, repudiation, information disclosure, or denial of service, and escalation of privileges. It is just a model of threats used to help reason and find threats to a system. It is used in conjunction with a model of target system that can be constructed in parallel. Like like other threat modeling models, Stride do not works only in ideation phase or just at the end cycle, but Stride is applicable during the whole product life cycle. Like at every step, you can think what we are building, what processes we have, what data stores we have, what data flows we have, and how we are creating the trust boundaries between all these data sources. Today, it is often used by security experts to help answer a simple question: what can go wrong in the system we are working on? Then we have PASTA. PASTA is basically a process for attack simulation threat analysis. It's a 7-step risk-centric methodology, just like Trike. It also works onto risk management thingy, but like it measures business impacts more from the attacker's point of view. The intent of this method is to provide a dynamic threat identification, enumeration, and scoring process. Once the threat model is completed, security engineers can develop a detailed analysis of the identified threats. Finally, the security controls can be enumerated again. The methodology is intended to provide an attacker-centric view of the application. So that's all about frameworks. Now, why we are thinking so much about threats? Why no one likes threats? No one does. But we cannot protect against anything we do not know about. So we need to know threats if we want to defend ourselves from those threats. So basically, threat modeling helps us to have a mitigation strategy and techniques based on the identified and documented threats. You basically identify and address the greatest risk. You prioritize threats, which threats you can accept, which threats you can circumvent with another technology. You increase the risk awareness in your organization. Then you basically, once you have threats and once you know how your risk exposure looks like, you benefit from cost justification and support for needed controls. You can use artifacts to document due diligence for each software project, each infrastructure project, any kind of project you have in your organization. Then some examples like how threats look like basically. And like we will be talking about examples only in the context of Stride, because otherwise it will be a lot of examples if we start picking every framework. So Stride, as I said, Stride stands for spoofing, tampering, repudiation, information disclosure, DOS, and elevation of privileges. Like every keyword in Stride impacts a particular paradigm of information security. So spoofing impacts authenticity, tampering impacts integrity, repudiation causes non-repudiability, information disclosure is breach of confidentiality, DOS is breach of like there is no availability, and elevation of privileges breach of authorization. So what is spoofing? Spoofing is basically illegal access and using that access to have information which you are not supposed to have. The basic example can be cookie hijacking. Like if, for example, if you have an application in your organization where you can, if you reuse cookie of another user, then you can basically log in into their account if there's no 2FA enabled. So that's a spoofing threat from that particular application. Then we come to tampering. Tampering is more about integrity, and like example can include unauthorized changes made to a persistent data, such as that held in some database and alteration of data, or maybe alteration of data when data is in flow from an open network to a computer, like man in a middle attack. You intercept thing and you manipulate it through a proxy. Then we have repudiation. Repudiation gets a bit complicated. Like repudiation is associated when you cannot uh, repudiation can cause non-repudiation, which is like when you cannot backtrack the actions of a user, backtrack malicious actions to a particular user. For example, if you have a application in your organization which can only have single admin, and you have three system administrator, and what they're basically doing are they are reusing single set of credentials between three of them. If one of them poses like is an insider threat to the organization and they do some malicious action, you cannot use the audit logs of that application to backtrack the activity of the malicious user, because all three users are using the same set of credentials. So when there is non-repudiation, logs becomes useless. So it is considered as a risk. And then there is disclosure. Information disclosure is just breach of information which should not be exposed, and it can be accidental share of files externally, like if some files are confidential to your organization and they get shared by human error or by insider threat outside the organization, then basically it's an information disclosure. In some cases you can reduce human error factor. For example, if you have shared drives in your company and human error can happen that one user accidentally shares your confidential data with someone external through just a single click. But you can enforce controls that, like you can have DLP policies on your shared drives that you can restrict the external share at all. So even if they make that error, it won't happen. Then there's denial of service. Denial of service is basically denying the service to valid users. For example, making a web server temporarily unavailable or unusable. Then we have elevation of privilege. An unprivileged user gains the privilege access and then compromise the security or destroy the entire infrastructure. Yesterday I was having an interesting discussion with a friend about elevation of privilege, that if if we have a project in a ticket management tool, and if we want to restrict that project from admin of that particular tool, then it's nearly possible, because admin can always give themselves privilege to have access to that project. So it's an issue. Then when to now we know what is threat modeling, how to do threat modeling. Now when to do threat modeling. Mainly threat modeling is done as a top to bottom exercise when certain benchmarks are met. For example, plan if you have plans of launching new set of features, if you have been developing new features, or you have like you're acquiring some companies, so maybe you want to threat model the coming entity, or you might be having a compliance requirement, or you might be needing a regulatory approval. So threat modeling matters because it gives you the risk score of your company, ties back to finances of your company. And like when the one use case which I always think is like, if an engineering team face some incident and they are doing root cause analysis, then they can do threat modeling during RCS as well. because even when the root causes of a more pedestrian nature, performing a root cause analysis can get the right people thinking about potential threats they may have ignored previously or they never considered them. Or maybe by patching that particular vulnerability, they might propose new dependency which may introduce unexpected security issues. Then otherwise, in my opinion, threat modeling perspective should be the way of life for every security engineer or like engineering team, as it promotes security by design from every aspect. A day comes when you don't have to do threat modeling exercise anymore because you are designing everything from the threat modeling perspective. You are thinking security before doing things, and it is applicable from application to infrastructure to your even physical security. So now when not to do threat modeling, we just said that we should do threat modeling by default, but when not to do it. Basically, I can think of only one thing when not to do it: when you have plenty of threats in your environment. And those threats are critical. You cannot just ignore them and find more fire hazards in your organization. As once a wise man said that you don't go and look for more fire hazards when your house is already on fire. Don't overwhelm your engineering team so they stop caring about the threats. As once Stephen Napo said, threat is a mirror of security gaps, but cyber threat is mainly a reflection of our weaknesses. Then my dad. My dad is a great threat modeler, and that's a good thing. But what he's doing wrong? He's doing this, he's making the same mistake what almost every security engineering team makes, which is threat modeling. Being good at threat modeling is one thing, and dealing with the outcomes of it is another. So if you are doing threat modeling, you are getting reports. How are you dealing with the results? Are you becoming overwhelmed? Are they becoming overwhelming to you, or like what's happening? So basically, two wrong things happen usually when you deal with the threat modeling reports. First is either security teams becomes too paranoid or engineering teams stop caring at all about them. And those are like usual cases, and they happen in lots of organization. Why they happen? Mainly security engineers, when get too paranoid, they become a bottleneck for every process or every everything coming. So we can start with risk acceptance. What is risk acceptance? Risk acceptance is like amount of risk your organization is willing to accept, and risk appetite is like capacity of risk they can, like diverse kind of risk your organization can accept to achieve its business objectives. Organizations basically recognize that they cannot remove all risks from their business, and like we exist in world full of risk, and for achieving our business goals, we need to require accept some risk and mitigate them or either transfer them. We can have compensating controls around the threats to reduce the threat and have then residual threats, which is like of lesser risk factor. Then what is risk tolerance? Risk tolerance is the amount of acceptable deviation from an organization's risk appetite. While risk appetite is a broad and like strategic term, risk tolerance is much more of a tactical concept that identifies the risk associated with a specific initiative or a specific project. While risk appetite is organization's appetite, and risk tolerance varies project to project. One way to understand this relation is, I was reading an article by Tech Target, and they presented it like, where, for example, when driving at very high speed on government roads is a high risk for the driver and to all the other drivers on the road as well. And government creates speed limits designed to control this risk. The faster a car drives, the more risk is created. So the lower the speed limit, the lower the degree of overall risk to the every driver on the road. However, lower limits also inhibits the flow of traffic, preventing vehicles from quickly reaching their destinations. Government must balance these concerns and determine the appropriate rate of speed, which is like government's risk appetite. Like how much risk they are willing to take to strike the balance between risk and threat. Then fun part, how I built a threat modeling function with just 3 people, including me in a team. And like it's totally doable. Just give them a perspective, just make them think, and just make them think how things can go wrong and tell them to spread that mindset. Like when I started in my organization, we were just 3 people, loads of features in product were coming, we were reinventing infrastructure, we were migrating to different technologies, hence threat modeling was needed everywhere. We were waiting on regulatory approval, we were waiting on compliance requirements, we had to do threat modeling at every step, and there were so many landmines in between. So in my experience, frameworks are good for to give you a mindset or perspective when you are new to threat modeling, but with time you develop it. Like frameworks becomes a bit hard to scale up or become a bit complicated for a big organization, and it's sometimes hard to go by the book all the time. So you can have your own framework, and you can decide how you want to measure the threat and link it to the risk factor. Then once you are proficient at threat modeling, then you pass on that mindset to every team. Then every engineering team learns to threat model of what's coming, and even gets better as they understand the product more than you. They understand the infrastructure better than you, as they're working on infrastructure all the time, and they see the gaps just better than you. Like I've been on calls where I used to do threat modeling, and now those developers or those infrastructure engineers are doing threat modeling way better than me, because they understand how it is working. I have to first understand the technology to highlight the threats, but they already know how it's working in detail. They just need that mindset to look into things, what can go wrong, and imagine every worst case scenario. And as I always say, that threat modeling is more than just an exercise. It's a mindset or a philosophy. I'll conclude my slides with like thanking to Max Rendell, who helped me brainstorming ideas and curating a raw idea about the threat modeling, and like supporting me into building the whole function in just 3 people. So any questions, you can always find me at Twitter and Discord. I'm quite active there and always open for a chat. Thank you.